All right, so here's your lesson on volume. Volume's a lot simpler than surface area in terms of the calculation. So this is called a rectangular prism. And the volume is simply, and order doesn't matter here. We're going to multiply each dimension together. So length, width, height. If you put the numbers in the wrong order, you're going to get the same answer. So 9 times 17 times 24. Now, here's something to be aware of. To write the answer correctly, we need our unit, or letters. But for volume, because it's 3 dimensions, it's going to have a little 3 to it. That signifies that we were doing volume. Remember, area had a little 2? 2 dimensions. 3 dimensions here, right? The capacity, we're going to have a little 3 at the end. So again, I look at it and go, okay, it's a rectangular prism. Multiply each dimension. So again, the order doesn't matter. Multiply each dimension and then get your answer. And remember that little 3 when you do it. Again, right? So much simpler than surface area. So multiply each dimension together. That's 3,744, and that's feet cubed in terms of the dimensions here. All right, what happens about other prisms, what you do? So for other prisms, we're going to find the area of the base times the height. So if the base is a triangle, what's the area of that base? So it's 1/2. The base is 12, and the height of that triangle is 7.3. And then we take that answer times the height of it, or the distance between the bases, which is 5. And that's it. And I get 219, again, feet cubed. So again, the area of the base. So for a prism, the base is the shape that's not a rectangle. If it is a rectangle, you're just multiplying the 3 dimensions together. So the shape that's not a rectangle is a triangle, so that's the prism it is. And so the area of the base, 1/2, 11 times 5.4. And then the distance between the two bases, which is 16. And that's it. I get 475.2. and that's inches cubed. Trapezoidal prism. So the trapezoid is the shape that's not a rectangle. That gives me the base. So that's 1/2. We add the two bases, so it's 36 and 14. We're going to add them. And then the height of the trapezoid is 17.9. And then we multiply by the distance between the two bases, or the height. So that's 25. And then multiply it together. Okay, multiply that right. That was a big number. Let's try it again. 0.536 plus 14 times 17.9 times 25. Let's see. That's a big number. So 1,187.5 meters cubed. All right, number 7. Again, the shape that is not a rectangle, so it's a triangle. Now, in this case, I need to know this side, because that's the distance between. Do I need to know that side? Yes, for the base and the height of the triangle. So I'm going to go x squared plus 28 squared equals 32.5 squared. And then to get x by itself, it's the square root of 32.5 squared, subtract 28 squared. So I'm going to use that in my calculator right now. So I get 16.5. So now I have the information that I need. So the area of the base, so a triangle is 1/2, and we have 16.5 and 28 times the distance between the bases, which is 31. So 0.5 times 16.5 times 28 times 31 And the volume is, again, a big number, 7,161, and that's kilometers cubed. Huge. 8. This is a trapezoidal prism again. That's a trapezoid. So the formula is 1/2. The bases of this trapezoid are 39.4 and 25. Oh, we add them. And then the height of this trapezoid, straight up, do I know that height? So you have 35. Try to see what we have to find this. Oh, here. But the height of this trapezoid, straight up, right here. How high is that trapezoid? So, in order to do that, I have 25. I have 39.4. That slant right there. So, all right, let's not do this one. I was just trying to think through how to find the height of that, and I'm looking through it. Must be something I'm not thinking. Because I know the distance between the trapezoids is 35. But the height of that trapezoid right there, this height right there, maybe, I don't know. Let me say it's a square at the bottom. Let's just say it's a square. All right. That's what you'd multiply it together. And I got 39,445 centimeters cubed. All right. The other one for volume, that's a prism, but it's a circular prism, is called a cylinder. And so it has its own, but it's the same thing. It's the area of the base, which is pi r squared, times the height, the distance between the two circles. So the radius here is 18, and the distance between the circles is 15, and that's what you type in. And I get 15,268.1, and that's inches cubed. Here we have a cylinder again. The diameter goes all the way across. So we're going to divide that by 2. That's 5.5. That's the radius. And now we're going to use the formula. So it's pi r squared times the distance between the circles, which is 21. And then type that in the calculator. And that's meters cubed. All right. A cylinder with 2 centimeters diameter is drilled through the triangular prism below. Find the volume of that prism. So, this is what I think is happening. That we're going to subtract. So the actual prism itself, compared to that, I don't know. I'm not going to do that one. Number 12. This is a picture of a pool. Plans to fill the pool to a depth of 4 feet with a garden hose that has 80 feet per cube per hour flow rate. How many hours will it take to fill the pool? So if you're going to fill it up to 4, this is going to be 4. And so the radius is half of 27. That's 13.5. So it's pi r squared times the distance between that, which in this case would be 4. And that's the volume. And then divide that answer by 80 to see how many hours that would take. All right, let's do that. And I get about 28.6 hours. Done. All right, there's your lesson on volume and prisms. Mr. G Math, over and out. Till next time.